Hi everyone, welcome back. Let's see a round robin algorithm with the example. Guys, round robin algorithm is going to execute based on the criteria of arrival time with time quantums. This is the reason we'll call this as FCFS with the preemption. So here the given data set contains process ID, arrival time and the burst time. And if you want to work with round robin algorithm, definitely you require time quantum, and the time quantum they have given as 2 units of time. So in order to solve this particular problem, we have to go with the Gantt chart. Right? So assume that this as a CPU and initially starting at 0 units of time, right? And I am going to take one more queue called ready queue, which is meant for to store what are the various processes that are readily available to execute, that are readily available to execute. Okay, fine. So at 0 units of time, what is the process available for us? P1 is available. So which will be entered into ready queue, right? As P1 is readily available, it will allocate the CPU P1. For what time it will allocate? It will allocate for particular time quantum, that is 2 units of time, right? Here round robin algorithm is going to work on the principle of time quantum, means once it got a chance to execute, it will allocate that respect to time only, 2 units of time. So it will complete it by 2 nanoseconds, or I can say it as 2 units. So while it is P1 is working, there might be some other process might enter into ready queue because of their arrival times are 1 and 2. So P2 will add it to the ready queue and P3 will be added to the ready queue, right, by the 2 units of time. Now as P1 is completing its work, it comes out of the ready queue, already it comes out, and it needs again the burst time. Am I right? It needs again, as it serves 2 units of burst time, it needs to come back again. So that's the reason it will be added. Now, next given chance to what? P2. P2 comes out of the ready queue and enter into running state. Right? While entering into the running state, how much it will be allocated? 2 units of time, and it will done by 4 units. Means P2 done its task for 2 units, so which means it left with the 3 units of time, right? But if you are able to observe, while completing 4 units of time, there might be some other process which might be entered into ready queue, which means process P4, process P5 also entered into ready state. And is P2 task is done? No. So that's why it is also make it a request in the ready queue in order to go for further execution. Next given chance to P3, allocate it for 2 units of time and complete by 6, right? By the time of completion 6, P6 also will enter into the ready queue, and it completed 2 units of time, so left with 6 units. Then after completion of P3 and coming out of the CPU, it will add it to the ready queue to make it again its turn, right? So guys, if you are able to observe, definitely after certain point of time, P1, P2, P3, P4, P5, P6 all got a chance, That's the reason we can say that round robin is having no starvation. Okay, next I will take out P1 entered into running state and allocated 2 units of time, completed by 8. By the time of 8, all are in the ready queue. Yes, so it will done its CPU time, so it will left with 0, right? As it is not required any kind of CPU, so it won't add it again further to the ready queue. Okay, next given chance to P4. P4 will execute for 2 units of time, completed by 10, and as it completes 2 units, it is left with 5 units, and I have to add in the ready queue again because I need further CPU. Next given chance to P5, completion time will be 12 and its time quantum is 2 units. So P5 left with 1 unit and again I need to add to the ready queue because I need further execution. Next P2 will execute for 2 units of time, complete by 14 and it left with the 1 minute of time. So again I need to go for ready queue in order for further execution. Next P6 comes out of the ready queue and execute for 2 units of time, complete by 16. As it execute 2 units of time, it left with 4 units and again it needs to add into the ready queue for further execution. Next P3 complete for 2 units of time and complete by 18 units and it is left with 4 units. Again you have to add it to the ready queue. Next P4 2 units of time, complete by 20 units and it is left with 3 units. So as it is having further CPU request, so I need to add to the ready queue. Next P5. P5, how much time it required? It required only 1 unit of time. So I will allocate only 1 unit and it is done by 21. So left with 0. So do I need to add further? No need because it doesn't require any kind of further CPU. Next we will go ahead with the P2 and requires for 1 unit of time. So it will complete by 22 and no need to add further. Next P6 will get the request. P6 will complete for 2 units of time, will be done by 24. As requires further, again I need to add here P6. Okay, next P3 will get the request and serve for 2 units, I think, yes, and it is left with 2 units. So as it is left with 2 units, I need to add to the ready queue once again. Next P4 got the chance, 2 units, complete by 28 and it is left with 1 unit. So again I need to add to the ready queue. Next P6 get the chance, 2 units, complete by 30. So left with 0. So no need to add to the ready queue. Guys, this process might be a kind of hectic process, but it is one of the efficient algorithm and which is a simple algorithm which can be implementable. Why it can be implementable? Because coming to SJF, guys, SJF, can it be implementable or not implementable? It is not implementable. The reason is here we need to working with the burst time, right? So predicting the burst times is going to be a difficult process. That's why it is not implementable. Coming to round robin, here as we are not working with burst times, we are working with only arrival time and the time quantums. Definitely it is going to be an implementable, right? So hope you understood, right? So coming to the problem, P6 completed task, then P3 will get the chance, P3 will get execute for 2 units of time and left with 0 seconds, 0 units of time. Then P4 get the chance for 1 unit, that left with 0. So it will done by 33. Done by 33. Guys, observe, is there any further process are there? No. As there are no further process, we'll stop the process here itself. Right? So this is the way your round robin algorithm is going to work. Now what is the scheduling length? L equal to completion time of all processes, maximum completion time of all processes minus maximum completion of all processes is what? 33 minus minimum of arrival time 0. So L will be 33, right? Like that you can able to go through various kind of factors which I have covered in the earlier videos. Once you have drawn the Gantt chart, you can able to clearly answer any kind of question. Hope you understood this video clearly.